Hello, everyone. Welcome to my virtual poster presentation. I am Xuefeng Hu, an epidemiologist from University of Ottawa. The title of my presentation is Predicting the Impact of Chemical Mixtures in the Environment on Nutrition on the Health of the Canadian Population. Before I go, here is a brief introduction about myself. I do have a mix of background, which is not related to machine learning or computer science, and I feel myself a little bit old for the summer school. Okay, I have a bachelor degree in medicine, then I go to a master of public health nutrition. Before I doing my PhD, I did some research in health economics, and then I go for a PhD degree for epidemiologist. Then I start my postdoc research in environmental health and indigenous health. Right now, I focus on analyzing the data from Statistics Canada. Okay, so in this presentation, I will mainly talk about three things. First is nutrients, then what is contaminant, and human health. So what are nutrients? I will give you a few examples like omega-3 fatty acid, vitamin D, calcium or iron. Those kind of things we basically feel is essential and good for our health. Oh, I mentioned about essential. Basically, nutrients are grouped as essential and non-essential. Mainly depend whether the body can make it or not. So the current approach is really we are setting up the dietary reference intake for various nutrients, and these reference intake values basically is defined by the percentiles from the population distribution. Approach works well from the perspective of avoiding nutrients intake inadequacy, but not that well to prevent chronic disease. To better understand how to prevent chronic disease from nutrient intake, or in the other words, we use the food as medicine approach. We need to know more about the dose-response relationship between each nutrient and the health outcome. On the other hand, the environmental contaminants is something the chemicals we don't need in our body, which are bad for our health. So some examples are like mercury, lead, persistent organic pollutants, or dioxins, something like that. So for most of the case, the adverse effect was observed from very high dose exposure, from the occupational exposure or some which are not relevant to the general population who exposed to low levels of such chemicals. And for this type of research, it's still really focusing on identifying the thresholds about which we start to see the adverse effect, but we are not clear about the dose response relationship, especially at the low dose. And another fact is that we are exposed to many of these chemicals simultaneously, but the research is really studied one chemical by one chemical, or one chemical to one health outcome. So the overall research objective is really to evaluate the associations between nutrients, contaminants, and human health outcomes systematically, because there's so many nutrients, contaminants, and there's on one hand. On the other hand, there are so many health outcomes. If we keep study the pair relationship between one chemical and one health outcome, we don't get a clear overall picture. So the ultimate goal of my research is really try to regroup nutrients or contaminants by their dose-response association with health, rather than group them as essential, non-essential, or group them by the contaminant source or the nature of the chemicals. My second research question is try to investigate the impact of chemical mixtures on human health instead of the pair relationship between one chemical and one health outcome. Eventually, I am hoping to see whether I can identify any potential biomarkers. These biomarkers are a group of biomarkers of either nutrients or contaminants, which can be used to predict long-term health, along with the traditional risk factors like age, sex, blood pressure, and etc. The data I'm going to use is really rely on the health surveys conducted by the Statistics Canada. For the nutrients intake, we have the Canadian Community Health Survey Nutrition, which covers about 50 to 100 different nutrients intake. For the nutrients and contaminants body burdens, we have the Canadian Health Measure Survey, which has approximately 300 different types of chemicals measured in each cycle. Right now, we already have 6 cycles. For the health outcome, cross-sectionally, the survey will ask the participants' health outcomes from the questionnaire, and then longitudinally, these data can be linked to the healthcare administrative data. Then we will have the hospital discharge and the vital statistics, which is more robust. Nutrients intake data, the participant is around 25,000. And for the contaminant side, the CHMS has around 5,000 participants per cycle. If we combine all the 6 cycles, the sample size is around 30,000. So now comes to my first research question: how to evaluate the associations systematically. What I'm thinking is maybe I can use the functional data analysis approach on the dose-response relationship, especially maybe I can use some type of the clustering technique, try to group the different type of associations. So this 3 graph you see is really from my own research. I'm looking at the same chemical, the effects on the same outcome from different populations. And then what we can do is try to adopt the same approach, but then repeat it for different chemicals and different health outcomes. Then we will have a pool of functional data, which is the relationship between chemical and health. Then we can apply the functional data analysis approach, try to see what are the best way to group or recognize the patterns between chemicals and health. For my next research objective, the chemical mixture and health, so I would like to start with the decision tree algorithms such as the card and random forest, and then try to explore the possibility of using deep neural networks to see what is the association between these chemical mixtures and human health. Thanks for attending my poster presentation. Welcome questions and comments.